So why is friction important in engineering? Engineers need to understand the force of friction so that they can design safe roads, tires, cars, and brakes. Kung papansin ninyo yung mga roadway natin kapag nakongkreto na, kumukuha sila ng lumber. Can you imagine what I'm telling you? Kumukuha sila ng isang wooden or good lumber or coco lumber. And then nilalagyan nila ng parang mga gilit-gilit yung top ng roadway natin, yung surface niya. Para medyo magaspang o gumaspang yung roadway natin, hindi siya pwedeng mapino. Can you follow? Can you follow? Hello?
Yes po, sir.
Okay. So, ganun ang ginagawa kapag nako-construct ng concrete pavement sa ating mga roadways. Doon sa pampinali, kukuha ng mahabang kahoy ang labor or ang helper, and then nilalagyan ng parang mga small linings or gilit-gilit para maging magaspang yung roadway natin. Kung papansinin niyo yung roadway, medyo magaspang ng konti, di ba? So para yon, kapag umaandar ang sasakyan, may nagpapagaspang ng roadway para lumakas yung friction. And then maging safety yung mga gumagamit ng mga roadways natin, lalong-lalo na kapag umuulan, slippery yung mga roadways natin. Okay? Engineers also try to reduce the force of friction between moving mechanical parts so that they will last longer. So yan ang dahilan. So yan kung bakit importante ang friction sa engineering. Okay, let's proceed. Why is friction now important to construct a building? Hindi pwede kasing marunong ka lang mag-compute. So what? Kung napakagaling mong mag-compute, napakagaling mong mag-integrate ng integral calculus, ng differential calculus, ng mga worded problems, alam mo ba kung bakit importante naman ngayon ang friction sa construction ng building? Sa palagay ninyo, bakit? Pwede ba kayong magmungkayo o mag-share ng opinion kung bakit napakalaga ng friction sa pagko-construct ng structure, mga future engineers? Any idea? Kanina, roadway ang halimbawa natin. Isa lang yun sa mga trabaho natin. Ngayon naman, how about sa structure? When we are constructing a building, ano ba yung role na ginagampanan ng friction dyan? Bakit napaka-importante niyan sa pagko-construct ng structure? Hello?
It prevents the structure po from falling po. Kumbaga ganun.
Para maging stable. Stability. Stability ng
Yes po.
structure. Para hindi ma-collapse. Para mapigilan yung pag-slide ng mga members. Let's see to it na laging nasa equilibrium ang mga joints natin. Tama ba? Yun ba yun? Okay, so
Yes po.
allow me to show it. May isa akong halimbawa na babasahin. Why is friction important to construct a building? And I would like to answer this by giving you a sample situation. The Alhambra Tower in Kuwait is basically built on desert sand. Kapag disyerto yung pinagtayuan mo ng building, ibig sabihin hindi maganda yung property ng soil. Not a very good soil to support a 400-meter tower. Malambot yung soil eh. So ibig sabihin, gagawa ka ng paraan para maitayo pa rin yung structure dyan. At may malaking papel na ginagampanan ngayon ng friction para makapagpatayo ka ng matataas at magaganda at magagarang mga building katulad ng Alhambra Tower. And even yung tower na create sa Dubai, doon sa dagat, importante yan. So ito yung itsura ng Alhambra Tower sa Kuwait. Yan. Kita niyo ba? Napakagandang structure. Lahat ng yan, produkto ng mga enenyero, ng mga civil engineers. And as well as also architectures. Okay. So ano bang meron dyan? Malambot yung lupa. So anong ginawang paraan ng engineer? Ng project engineer, ng project manager, ng contractor? But there is an engineering solution known as friction piles. Para mas lumawak yung kalaman ninyo sa construction, friction piles ang ginawang solusyon para maitayo ng maayos ang building para mas maging stable ang structure ng Alhambra Tower. The piles usually very large, have a large surface area that rubs against the soil creating friction. The friction force is calculated to be sufficient to hold up the building's footings. So para safety ang pagkakatayo ng structure. Ginamitan ito ng friction piles. Karagdagang kaalaman, ano ba ang itsura ng friction piles? Yan ang friction piles. Friction piles are driven at a site where soil is weak or soft to a considerable depth and it is not economical. Hindi siya ganun lang kamura, no? Hindi siya mura, mahal siya actually. Very expensive. Or rather possible to rest the bottom and end of the pile on the hard stratum. Kasi kapag malambot yung lupa, actually, malalim na ukay yan eh. Inaanap pa natin yung pinakamatigas na soil portion ng ating kalupaan sa ilalim. Kapag na-meet na yung pinakamatigas na portion ng soil or layer ng soil, doon ka palang magde-decide. So magkakaroon tayo ng piling. Okay? The piles are driven up to such a depth that skin friction develop at the sides of the piles equals the load coming on the piles. So ganyan kaimportante ang friction sa pagtatayo ng structure. Specifically, sa Alhambra Tower ng Kuwait, kung paano yan itinayo. Ginamitan yan ng friction piles. Napaka-importante ng foundation sa structure. Gaano man kaganda ang physical appearance niyan, kung di maganda ang foundation, mababaliwala yung kagandahan ng structure, yung panlabas na kaanyuan niyan. Kailangan maganda ang pundasyon. Klaro ba? Ang ibinigay kong sagot kung bakit importante ang friction sa building structure or construction of a building. Malinaw ba ang halimbawa natin? Klaro?
Sir. Yes po.
Hindi
Yes,
pwede
sir.
kasi class na solve lang kayo ng solve ng mga problem. Ang galing mo mag-solve ng integral calculus. It makes no sense kung di mo alam ang ginagawa mo at patutunguhan ng lahat ng iyong ginagawa. Ang nahihirapan kang mag-solve, nagme-memorize ka ng formula. Ano ba yung kabuluhan ng ginagawa mo? Kailangan alam mo kung bakit ka nagpapakahirap sa pagsosolve ng mga problems. Definitely, may patutunguhan ng mga yan para maging fit yan into real life situation para marami kang ma-produce ng mga structure na magaganda at mga matitibay. Yun ang dahilan kung bakit kayo pinahihirapan sa mga calculations. Kasi hindi naman biro-biro yung mga structure na itatayo natin. Ang daming mga buhay ang nakataya. Understanding the sliding friction. The amount of sliding friction created by objects is expressed as a coefficient which takes into consideration the various factors that can affect the level of friction. These various factors that can impact sliding friction include the following. Ito ang mga sumusunod para mas maintindihan ninyo ang sliding friction. The surface deformation of objects, one consideration. The roughness or smoothness of the surface of the objects. The original speed of either object. The size of object, lahat ng yan may kilalaman sa sliding friction. The amount of pressure on either object. The adhesion of the surface. Ano bang ibig sabihin ng adhesion? It is actually the steadiness or firm attachment. Yan ang ibig sabihin ng adhesion. Para mas klaro, para mas malinaw, shortcut ko na lang ang definition. Steadiness or firm attachment. Wala nang diretsong paligoy-ligoy. Everyday examples of sliding friction. So nagbigay ako ng mga halimbawa para mas ma-visualize ninyo yung tinatawag nating sliding friction at napakarami niyan. When we rub our both ends together, we create it. That is because of friction. A sled sliding across a snow or ice, skis sliding against snow, a person sliding down a slide is an example of sliding friction. Pakibasa mo nga, James. Susunod.
A coaster sliding against a table.
Okay, that's another example. Magnaye.
A washing machine pushed along a floor.
Another example. Leia. Leia Manalili, nandiyan ba? Okay, wala na. Absedi.
An iron being pushed across material.
Okay. Next example. Aira.
The frame and the edge of door sliding against one another.
Another example yan. Baby Gale.
The bottom of a trash can sliding against the concrete.
Okay. Billy.
A block being slid across the floor.
Okay, next. Christine Joy. Di tayo maubusan ng example. Sobrang dami niyan.
Two cement blocks being slid into place next to each other.
Okay. Darwin.
Two cards in a deck sliding against each other.
Okay, that's very good. Dean.
The bottom of the glass being pushed across the table.
Jan.
Couch sliding against the steps when being moved.
Okay. So, more example pa tayo. James. James. Balagtas, James. Pakibasa. Saan si James? James.
Ayaw daw po mag-open ng mic niya.
Okay. Kyle Bino, pakibasa. Mr. Bino. Kyle. Okay, wala si Kyle. Joshua Bino na lang.
Dresser slides on the carpet when being slid to another part of the room.
Okay. Next, Mark.
The rope and the pulley on a set of blinds or curtains.
That's another example. Yuson.
The friction between two books and sliding one into place on a book set.
Okay. Reyna Ann Bernabe.
The friction between the bottom of a book and the shelf when being slid into place.
Okay. Mark Makalas again?
A vegetable drawer sliding against the holder in the fridge.
Christine?
A check being slid across the counter at the bank.
Okay. Jaen?
Paper sliding against the paper folder once emitted from a copy machine.
Magnaya?
A paper on the roller as it slides through a fax machine.
Okay. So many examples that we have. Actually, araw-araw, na-encounter natin ang tinatawag na sliding friction. Kapag naglalaro ka na lang, may sliding friction. Di ba? Kapag nagpapaslide ka, tumatakbo ka, nung kabataan mo pa lang, nung nakikipagpatintero ka, laging nandyan ang sliding friction. And even when we construct structures, importante din ang sliding friction. Kaya nga lang, prevent natin yan, yung pagkakaroon ng slide of two surfaces para maging equilibrium yung mga members ng structures natin. Now, let us have sample problem number 1. Let us apply now all what we have learned from our brainstormings kanina sa mga formula na na-introduce ko regarding about friction. Sample problem number 1. A 200 kilonewton block shown as impending motion up the plane caused by the horizontal force of 400 kilonewton. Determine the coefficient of static friction between the contact surfaces. So, yung surface na kung saan nakapatong yung block at yung mismong surface ng ating 200 kilonewton block. And then, so happen na may horizontal force na 400 kilonewton na acting doon sa 200 kilonewton block natin. Definitely, ang weight ng ating block is 200 kilonewton at ang force applied is 400 kilonewton. Pinapahanap ang coefficient of static friction between contact surfaces. And yan ngayon ang ating bibigyan ng katugunan o solusyon ang ating problem. Hopefully, maintindihan ninyo ang solusyon because eventually, marami akong mga problems na ibibigay sa inyo regarding about friction. And also from our previous topics also. Yan yung isa yung topic na yan na maglalagay ako ng mga 50 worded problems. So this is the figure para hindi na kayo mahirapan mag-visualize. Actually, naka-slant 45 degree yung inclination niya. And then, sinadya ko na sa figure na magkaroon ng 30 degrees and theta doon sa ating R. R first. Yung 400, nag-a-act siya doon sa corner ng ating block of wood. And then yung weight, syempre hindi naman babago yan. Ang direction niyan is laging downward. So yung weight ng ating 200 kilonewton block of wood is 200 kilonewton actually. So how do we solve now the problem? As the problem solver of the problem, and kunwari ako yon, ginawan ko muna ng pre-body diagram. Inalis ko muna yung object and I've created it this way. As we can see, we have the angle from this line. In-isolate ko muna yung figure. From this line, ito, we have 30 plus theta, yung angle na yan. And that is now the 400 kilonewton. In-isolate ko sila, no? And 200 kilonewton na weight ng ating, ito yung weight Ito actually yung ating applied force. And yung R will play the role of our normal force actually. Naka-inclined Kaya lang ito 45, ito nga naman is 30 plus theta. So how do we solve the problem? Ganito kung sinolve ang problem para may diskarte kayong makita, no? Una, nag-try go muna ako. Saan ba nanggaling ang R cosine 30 plus theta? Iba nga lang yung symbol ng theta natin dito, no? Gandahin natin. That must be like this. Okay? R cosine theta plus 30 is equal to 200. Now, if I'm going to revise that R cosine 30 plus theta, actually, yan ito rin yun Cosine 30 plus this one is equal to 200 over R. Tama ba ako? Tama ba? Para mas maintindihan nyo lang. Hello? Are you still with me?
Yes, sir.
And in trigonometry, if we talk about the trigonometric function, what is the definition of cosine of an angle? Ano ba yung cosine ng angle sa trigo? Ano ba definition?
Adjacent.
Ano?
Adjacent.
Over?
Adjacent overhead.
Hypotenuse. So, ibig sabihin yung R is hypotenuse, di ba? And ito yung 200 is adjacent. Huwag kayong magpapalito sa figure na yan. Actually, ang gagawin nyo lang is to create a triangle first. Di ba? Ito yung R natin. Yan. R. Yun yung direction niya. 400 doon ang direction niya. 200, ito yung direction niya. I-convert nyo yung free body diagram natin. Free body diagram, ibig sabihin wala na yung mga object. Inalis muna natin para hindi malito. Kinonvert muna natin sa mga arrows and angles, sa mga givens. So, ganyan itsura ng free body diagram natin. So, this is 200. And this is actually 400. And this is the 30 plus the angle. These are hypotenuse with this R. Siset yung reference angle natin, adjacent over hypotenuse. So, R cosine 30 plus theta is equal to 200. Na-originate actually dito. Can you follow? Sunod. Diskarte,
Yes, po.
tinuturo ko sa inyo, diskarte yan. And then, kinuha natin yung cosine, kinuha na din natin ng sine. So, 200, ibabaliktad. Dito ba dapat yung theta plus, Parang baliktad yata, no? Tama ba? 200, adjacent. So, ibig sabihin, dito yung angle natin. Correct ko lang, no? Di kasi ito 200 yan, 400 ito Ito yung 200 So, hindi dito yung position ng angle natin. Okay, correct natin, no? Di kayo kumikibo. Ito yung 30 plus theta. Yan. To make this realize. Kasi ito yung angle, di ba? So, dapat doon nga naman siya. Can you follow? Dito siya. Dito. So, that's why this is our adjacent. That is our hypotenuse. And this is going to be our opposite. That's why this was realized. Klaro na? Klaro na ba? Klaro na? Hello?
Yes, sir.
po.
So, doon yung angle kasi dito ito yan Okay. So, same. Sin theta plus 30 is equals to 400 over R. Opposite over hypotenuse. Ito nang galing. So, ang susunod akbang na ating gagawin para makapag-solve tayo ng mabilis. Kasi ko lang yung figure, no? Okay, i-quit ko ulit. Saan ba? Dito na lang. Yung angle na yan, ito yon. This is 200. This is 400. And that is R. Para mas klaro. Okay, so let's proceed. By ratio and proportion, kung ang R cosine theta plus 30 is to 200, ito yan. Yan. R cosine theta plus 30 is to this. 200 is to 4. So, we use ratio and proportion. Can you follow? Can you follow? Class? Hello?
Yes, sir.
Now, if we're going to apply ratio and proportion, when actually ratio and proportion, basic math lang yan eh. Importante pala sa physics ang ratio and proportion, ano? Cancel both R. But cosine over sine sa trigonometric identities is what?
Tangent.
Cotangent. 200 over 400 reduced to lowest term or decimal, this will be equal to what?
1/2.
1/2 or 0.5. So sa makatuwid, magiging ganyan na lang equation natin. Napakadali lang pala. Naging madali kasi ginamitan natin ng ratio and proportion at saka ng mga trigonometric identities at saka ng principle ng trigonometric function. Yan ang reason kung bakit hindi pinapatik up ng physics ang ibang mga estudyante na hindi pa tapos ng trigonometry at ng mga basic math. So, we can now calculate for 30 plus theta. Theta is equals to 33.4. R cotangent yan, no? Para magamit mo ang R cotangent dahil may tangent, ang cotangent is also 1 over tangent. Identities uli. Kasi walang cotangent sa calcu eh. So, ang gagawin ninyo, yung cotangent, instead na ganyan ng pagkakasulat, magiging ganito yan, class. 1 over tangent 30. Sa susulat king kaya na. Iba talaga kapag on the spot at saka actual, hindi yung online. Okay, equals 0.50. Can you follow? Class?
Yes, po.
Okay, so assuming nasolve na natin ng theta, 33.4. So continuation ng ating computation. Yan. We can now calculate for the mu. Diba, ibinigay kong formula kanina sa static friction. May binigay akong formula ever since sa simula pa lang. Kaya mga balikan ko nga, pakita ko sa inyo. Ito yun eh. Anong slide to? 10? Binigay ko yung mga formula sa inyo kanina, mga anak. Ito yun. Diba? At ito yun. Theta S. Okay, so let's proceed. Let's go back. Para yatang mali. Slide 10, no? Okay, ito. Dapat pala from current slide. Yan. What's next? Mu S is equal to 0.66. So, nakalculate na natin finally ang ating coefficient of static friction between the two contact surfaces is malinaw ba? Klaro ba? 0.66 ang ating coefficient of static friction. Question so far? Wala ba kayong tanong sa problem number 1? Klaro ba ang ating calculation?
Klaro pa naman, sir.
Okay. Next. So this is now our problem number 2. The 500 kilonewton block shown is in contact with a 45 degrees inclined plane. So inclined plane yan, no? The coefficient of static friction is 0.25. Compute the value of the horizontal force P necessary to A. Just start the block up the incline. Just prevent motion down the incline. Letter C. If P is equals to 400 kilonewton, what is the amount and direction of the friction force? Yung R at saka yung theta, yun ang tinatanong sa pangatlo, no? Yung una, hanapin siguro natin dito ang P. Pangalawa is P. And then the third one is yung friction force, yung amount at saka direction nito. Ibig sabihin, kailangan natin ng angle. So, this is the figure actually. Yan. Okay. Tingnan niyo muna maigi yung problem. Basahin mo lang yung maigi sa isip ninyo. And then, i-try ninyong i-analyze. Try ninyong mag-imagine kung paano natin yan isosolve. Baka may maisip kayo. Prepare na ba kayo? Okay na? So, yung 500 kilonewton block is in contact with a 45 degrees inclined plane. Ito yung inclined plane natin, naka-incline ng 45 degrees. Ito yung block of wood natin. So, may contact between two surfaces. And someone is actually pushing the block of wood. Laking wood naman yan. Okay, no? Tinutulak siya. And then, it so happen na yung force applied to this is an horizontal force, P. Horizontal force, P. Palagay ko, ina-handle lang yata niya eh. Okay, so let's proceed to the solution. Yan, ito yung ating figure. So, in-isolate ko muna siya, no? Yan yung unang figure natin para ma-solve yung problem. Kasama yan sa problem, no? Nakadrawing ka agad yung figure. Okay, let's start with our situation 1.
Question po.
Yes.
Given na po dyan yung yung second na picture, sir?
Oo,
Or
given.
hindi pa?
Given na. Given na kagad. Hindi ka naman pwedeng mangula ng mga 59 degrees and 45 degrees na yan eh. Given na kagad yan. Okay? Ibinigay na kagad. Kasi hindi mo masasolve yan kung walang binigay na given na mga agad na figure eh. Manguhula tayo kapag...
Okay po, sir.
Okay, given na kagad yan.
Thank you po.
The solution. Solving for P. Una, tangent theta is equals to mu. Tama? Binigay ko kanina yan. Tangent theta is equals to 0.25. Okay, balikan ko Saan ba nanggaling 0.25? Yan ang coefficient of static friction. And that is actually equal to tangent theta. And then we can calculate for theta, which is actually equal to 14 degrees. 14 degrees. Okay, so proceed tayo. May 14 ba dito? May 14. 14 yun.
Meron
Yes,
po.
sir.
Okay, 14. Nakuha yung 59, no? Okay. Next. R cosine 59 is equals to 500. Saan nanggaling yung 59? Balikan ko uli yung problem. Hindi ba 45 ito kanina? 45 hanggang dito. Eh, naging tayo ng 14. Tama? Just start the block up the incline. Nagay tayo ng 14. So, naging 59. Nagay ba? Nagay nyo? That's why we have now this. Can you follow? Can you follow?
Yes, sir.
Okay, so proceed. Saan nanggaling yung 59? 45 plus 14 is equal to 59. So, ayan yung three body diagram natin. P, 500, and R. And with this, by creating triangle, makakapag-solve na tayo. R cosine 59 is equals to 500. Ibig sabihin, 500 is adjacent and R is hypotenuse. Tama? Kung nag-construct tayo ng triangle, kung balikan natin uli yung kanina, nag-construct tayo ng triangle, ito siya, assuming yan. Ito yung R, ito yung 59. Nasulat ko. And then, ito yung 500. Ito naman yung P. Tama ba? Tama ba ako? 59 yun.
Opo, sir.
59 ito,
Tama po.
59. Okay. So, balikan natin yung ngayon. That's why we have calculated for the value of R, which is equal to 971. Tama ba? Na-compute na natin yung R. Na-compute na natin yung angle, yung 40 degrees. Alam natin kung saan nanggaling yung 59. We can now calculate for the value of P using the same figure, just like what we did kanina. O, di ba, alam na natin ang value ng R. Malalaman na natin ang P. Can you follow kung paano ko diniskarte yan? Hello? Try ko lang.
Yes, sir.
Okay, so let's proceed. So, nasolve na natin ang P. And P is equal to 832 kilonewton. Okay? Sagot sa unang tanong yan. Pangalawa, second situation, and this is it. Okay. So, ano bang ginawa ko dyan? Solving for P again. Okay. Dito naman yung R. Lampas ng 14. Lumabas sa 14, no? Paano kung dito yung R natin? Ano ba yung talong? Balikan ko nga. Just prevent motion down the incline. O, ibig sabihin, before, nung 14 degrees, di ba, no? O, ito yan. Nandito yung R natin ngayon, 31 and 14, no, sa 45. Dito ka magle-less ng 14 degrees. Di ba kanina 45? Kanina ganyan yan eh. Dito yung R natin kanina at ito yung 45, doon naman yung 14. Ngayon naman nag-less ka ng 14 sa 45 kaya 31 yan. Nagigets nyo ba? Nagigets nyo? Hello?
Opo, sir.
Okay, so nag-less tayo ng 14 degrees. So, eto ngayon yan. Again, you draw a triangle just like what we did. Again, we proceed to triangle. You create a triangle and then apply trigonometric functions. Solution, solving for P. May mga angles na tayo eh. R cosine 31, calculate for R, 583. Na-calculate mo lang R, makukuha na ang P. R sine 31, then P is 583 sine 31. And that's it. Sine 31. Oh. P is 300 kilonewton. Malinaw ba? Malinaw ba second problem? Di ba tapos yan? Klaro ba ang pagkakasolve? Hello, class? Hello, are you still with me?
Yes po.
Okay, kanina naging 59, ngayon naging 31 na lang. Okay, situation 3. And this is our figure for situation 3. Yan. 40